So moving on to question number 4, which is on our integration. We are going to consider this part, all right? Determine the integral of y with respect to x in each of the following cases. All right, so we were given 4.11. All right, that is the integral of this. This is y there, so meaning to say that was gonna give us the integral of x into 2 minus 3x, all right, everything over e to the exponent of 3x plus x squared. So that is with respect to what? With respect to x. All right, but they gave us an important aspect, something very, very important, this hint. You are told that let u be this expression. Let u be that given expression if our u is equal to 1 plus x squared e to the exponent of what? Minus 3x. Can you integrate this? Simply, they are telling you which method to use or to apply by substitution method. This is algebraic substitution. If u is equal to this, what are you going to do? We are going to need to find an expression or a representative for what? Dx. What represents dx? Meaning to say, you must differentiate u with respect to x. All right? So this was going to give us a 0. That's a constant. And here we've got what? A product. So to differentiate these guys, a product, we've got u and v. Remember the formula. All right, so this is it. Our u is what? X squared. So that was going to be x squared times the first derivative of v. They simply going to drop the power. All right, and it remains as it is. Remember your exponential plus our v e to the exponent of minus 3x. All right, times the first derivative of what? Of u, which is simply drop the power. That's what? 2x. All right, so this is it. What we can do, we can also like factor out. Let us consider what is common here. We've got x is common and e to the exponent of what? Minus 3x. So let's factor it out and see what you're going to have in this case. All right, this is going to be negative. All right, so you can start with this one with a positive. If I factor out x and e to the exponent of 3x, I'll be left out with what? With a 2. All right, this one is going to give us a negative. So if I factor out x here, it's going to be x squared divided by x, which is what? X. E to the exponent of 3x, I'm going to be left with 3 there. So it's minus 3x. All right, that's minus 3x because this one is going to cancel. X squared and x is going to give us x. So that's minus what? Minus 3x. All right, so this is our dx, our du dx. All right, so what about dx? Because we need to substitute to replace that one with its equivalent from here. All right, so our dx, you're going to cross multiply, then definitely you divide by this to what? To du. So it is simply du over this. All right, you made dx the subject of what? The formula. Let us now take this in place of our dx and see how it was going to look like. All right, this was going to be the integral of x into 2 minus 3x over what? E to the exponent of 3x plus x squared. This is what we have. All right, times the dx, which is this part that we have. So that's du over what? X e to the exponent of minus 3x 2 minus 3x, like this. All right, so this is what we now have. So let us simplify. From what we have here, we can see that there is something common between the numerator and what? The denominator. X and x can cancel. All right, 2 minus 3x, 2 minus 3x. So you are left with this part and e to the exponent of what? Minus 3x. So this was going to give us something like this. All right. It was going to give us something like this. Du in the numerator over what? This e to the exponent of minus 3x multiplying this expression. This is an expression, so it must what? It must multiply. So you simply have to open bracket e to the exponent of 3x plus what? X squared. So this is what we have. And we must integrate with respect to u, but we still have what? X. We still have x. All right, let us try to simplify because so far we do not have anything that is equivalent to what? To that u that we are given there. But if we were to expand these brackets, I want you to see what was going to happen here. If you're going to expand, multiply this, this was going to give us e to the exponent of minus 3x times e to the exponent of 3x. Multiply to this one, this was going to give us plus x squared e to the exponent of minus 3x. You expanded the brackets. And here, since we are talking about the same base, you simply have to add the exponents under multiplication. So that was going to give us what? That was going to give us a 0. E to the exponent of 0, which is what? Which is 1. Plus x squared e to the exponent of minus 3x. Guys, this part here, if we look into the given part that we're given, it is exactly as our u here, this one. So, okay, let us just write it first so that we can properly show our steps. So here I just expanded on this part. So this is what I'm going to write, the integral of du over what? This part. 1 plus x squared e to the exponent of minus 3x after expanding the bracket. But this whole part that we are seeing here is equal to what? Is equal to u. That's our u, guys, if we consider properly what we are given here. This whole part, 1 plus x squared e to the exponent of minus 3x, 1 plus x squared, it represents what? It represents u. So we can substitute that so that we can integrate with respect to what? With respect to u. With respect to u. So that was going to be integral of 1 over u. All right. Sorry, let us just write du. Du over what? U. This is the same as 1 over u times du. And the integral of 1 over u is what? A ln 1 over. So that's ln u plus what? The constant of integration, right? Where's our integration? But that part you're supposed to know it by head. I don't even know if they gave us this. There you see, we are not even given this, but you can take it to vice versa of this. These are derivatives. Remember, this represents ln of x. So if you integrate this, is the opposite. You're going to obtain what? Ln of x. So that is how you can play around from the formula sheet, all right? So that's ln of u. But u is equal to what? Remember, u is this in terms of x. So you're going to replace it so that our answer is what? In x. The integral from our question was what? With respect to x. So we must have our answer with x. So that's our u, this one. So place it there in place of what? U. That's 1 plus x squared e to the exponent of what? Minus 3x plus the constant of what? Integration. So that is the whole idea. We are done. That is the whole idea. We're given this. So just substitute. You're done. So you see, when you're given a hint, you follow what you're given. In this case, you're not going to choose your own to say this is what represents you. No, you are given what represents you. So play around that until you go back to that you and integrate with respect to you. You cannot integrate what is of x with respect to you. It's impossible. So you must have what represents you. So in our case, this is what we had. It was just direct u like that. Sometimes you must play around until you get that u means something that is in terms of u, so that you can simply integrate. But that is it, guys. Let us consider another part, 4.12, which was to integrate this. All right, that's a cos and what? A sine raised to odd exponents, 7 and what? And 3. These are odd numbers. So that's the integral of cos to the exponent of 7x, sine to the exponent of 3x with respect to x. Remember, on our integration, if m and n from this idea, the integral of sine to the exponent of mx, cos to the exponent of nx with respect to x, if m and n are odd numbers, you split. For it to be easier, it is wise enough for you to split the smaller power, split the trig that has got what? The smaller power. You must split that one using what? The idea of our identities. If it is cos, you use the cos, but in our case, the smaller power is what? Is 3. So you use this identity. Sine squared ax is equal to what? 1 minus cos squared ax. So if it is that idea that we need a sine squared, we are going to split this sine to the exponent of 3 to be written in terms of what? A sine squared. So that will be sine squared x. But we must obtain this. You are simply splitting it, but obtaining the same sine cubed. So what are we supposed to do? We are supposed to multiply by the sine of x so that we obtain what? Sine cubed x. So that is to split. To split. So this is going to represent sine cubed. This part is going to represent sine cubed. So that is the first thing to do. So that's the integral of cos to the exponent of 7x times what we have splitted here. Cos, where am I getting the cos now? The sine squared of x times what? The sine of x with respect to what? With respect to x. So we managed to split this. Where we have a trig representing the sine squared of x, it means we can substitute that in place of what? A sine squared. That was the reason of splitting, because we had to split in terms of what? A sine squared, so that we can have its substitute. All right? So we must what? Substitute that. So it's the integral of cos to the exponent of 7x into what? The sine squared of x, which is what? 1 minus cos squared. 1 minus cos squared x. All right, as it is here, it's x, so this one is going to be also x, times this one, there's no substitute, it's just going to remain as it is, the sine of x dx. All right, so some, depending with the understanding, your textbook and so on, you can only expand the cos and leave this sign on its own, or you can expand it by both cos and the sine into the bracket. So you multiply this here. All right, so that is going to give us what? That's expand brackets here. Let us expand brackets. All right, so this is going to give us cos times 1. That's cos to the exponent of 7x, sine times 1. That's a sine of x. All right, with respect to what? With respect to x. Then we expand again, multiplying what? Multiplying cos squared. So this cos is going to multiply cos squared. Sine also is going to multiply cos squared. So that's minus the integral of cos times cos. You add the exponents because these are what? Same bases. So that's cos to the exponent of 9, 7 plus 2. All right. The sine dx multiplies also. So that is the sine of x dx. So this is what you have. You can integrate each separately. All right. What is the best way of integrating when we have a cos and we have a sine at the same time. We can use substitution method, or we can use, remember, I talked about easier ways, that is by inspection. All right, by what? Inspection. Let me write this one. You could have used substitution, or by what? By inspection. I'm going to just apply both. By what? Inspection. I don't know if I had this part as a separate playlist, but we are going to try by all means, guys, so that you understand more. There are so many ways of integrating. All right, so many ways. So I'm just gonna check again if I did this one as a separate by inspection. All right, these are the formulas that you're given in your formula sheet. Let me show you. Is it for N6 or for N5? But let's see. All right, this one. These formulas here that you're given here, they are for this first one, it's by parts. Then these ones, these two that we see here, they are formulas which can be used in a shorter way, in an easier way. We can apply these formulas in an easier way. That is by what? By inspection. These formulas that we see here. All right. So what we are referring in our case, if we check properly, what we are referring in our case, I want us to see here on our question. It is the cos raised to a certain power. Then we have got the sine. Here, the relationship that we have between cos and what? And the sine is that sine is from the derivative of a cos, though it's what? A negative. The derivative of what? A cos. The derivative of a cos. If you differentiate a cos, when you say f of x and its derivative, so cos x gives us what? Negative sine x. So even though there is what? It's a positive. So what you can do to obtain a negative, if you are using by inspection, you can adjust your question. All right, since the derivative of what? Cos of x gives us negative sine of x. But in our case, the derivative here is given as a what? As a positive. All right, let me write the formula, guys, so that we can understand each other. The formula is the integral of f of x to the exponent of what? To the exponent of n times its derivative. Its derivative. Its what? Derivative. It's going to give us f of x to the exponent of what? N plus 1 over n plus 1 plus the constant of integral. That's what you simply do. If this is a function and this is its derivative, you simply take this formula. You take your f of x to the exponent of n plus 1. But in our case, cos gives us a negative what? Sine. So meaning to say we must put a negative to balance this, because here it is giving us a negative, but we must put what? We must have a positive. As you can see, it's positive. So it is either you just put a negative here, this one, you put a negative here to say the derivative there is now a negative, so that this one will be a positive. Negative times negative gives us what? Positive sine x. But you know that the derivative of what? A cos, the cos that we're referring to is what? Is a negative. So this f of x here, representing cos, cos is our f of x, it is going to be taken as what? As a negative. So that sine will be positive. We want to have a positive here. So this is the idea, all right? So meaning to say, using this formula, it is going to give us what? F of x to the exponent of n plus 1. Our f of x is what? It's minus cos. So it is going to be minus cos in our case, all right? So that's minus cos to the exponent of what? 8, you add. Remember, this is n plus 1, n plus 1. So that's plus 1, which is 8, to the exponent of what? To the exponent of 8 over what? N plus 1, which is over 8. So we have used the inspection in our case. All right. We move on to the following one. It is the same thing. This is a cos, this is a sine. The only thing that differs is the sine, the power. But we're going to have the same thing as here. So it's going to be minus cos to the exponent of what? We add 1 on our exponent. So that is to the exponent of what? 10 over what? The power that you're given, 10, like that. So this is it. You add your cost of integration. You have used inspection method. So that's negative cos to the exponent of 8x over 8 minus minus, that's a plus. Cos to the exponent of 10x over 10 plus c. That's it. You're done. So you can use that. It is part of your what? It is part of your N5. You have those formulas so they can be used. Or we can use our substitution method as we are used to that one. All right. Let me play around with your substitution method, which is most of you are used to choosing u. So that's another way by what? Substitution. We can let u be equal to what? The cos. Remember this raised to the exponent. So that is the same as here. So you can take u to be cos of x. So therefore du dx is going to be what? Negative sine of x. Make dx the what? The subject. So dx is going to be minus du over the sine of what? X. So this is what you're going to have at the end. So it's the integral of cos u. All right. Our cos is what? U. So that's u to the exponent of 7 times the sine of x, of which it was going to cancel if you see here, times our du. All right, let me just write for the sake of all of us understanding. Minus the cos u to the exponent of 9, the sine of x. Our dx is what? Minus du over sine of x. So this is it. This one and this one cancels. Take the negative out. So that's minus u to the exponent of 7 du. This one and this one cancels. Take the negative out. Is what's going to be positive u to the exponent of 9 du, like that. So we can simply integrate minus, add the power, add 1 to the power, u to the exponent of 8 over 8 plus add 1 to the power, u to the exponent of 10 over 10 plus c. But remember, it is in with respect to x. So what represents x? Remember here when we made the substitution, u is represented by what? Cos of x. So in place of u, put that cos. So that was going to be cos minus cos to the exponent of 8x over 8 plus cos again to the exponent of 10x over what? Over 10 plus our constant of integration. So as we can see, it was still going to, we are still going to have the same answer as before. Guys, mathematics, so many ways. Don't be limited. So many ways. So if you have another way, let us communicate. Let us communicate. There are so many ways that you could have applied to integrate thereafter. But these are the stages that you're going to need. All right. It is easier for you to split the smaller power. You do not have a lot of calculations for that one. All right. Let us move on to 4.13. Still on our integration. All right. Still integrating. 4.13 for 3 marks. All right. Let us see what you're given there. There is a cos and a cos, a product of a cos and a cos, and both are raised to the exponent of 1, guys. These are like linear. We do not have any power that is affecting cos or that is affecting sine. We do not have any power there. All right. So meaning to say, if it is like this, guys, we are limited. All right. So let me just change here. I don't know why it is like this now. All right. The sine of what? Pi over 4x with respect to x. We do not have this one to the power of 2 or to the power of 4, whatever. We do not have that condition. So what are we going to do? Remember that we can change a product of a sine and a cos, whatever that you have, to a sum. Product to sum from our identities. All right? A product. In this case, these are the ones that we have here, the products here can be changed to sums and what? Differences. So in our case, it is cos of what? We can call this one A and this one B. Do we have cos A sine B? Cos A sine B. Sorry for that. Here, cos A sine B. So we are going to use this identity, this one. So it's going to be half of sine A plus B minus sine A minus B. All right. Remember, all right, just for the sake of time, guys, let me just rewrite our question. Remember, it was sine of what? Sorry, it was cos. Let me do it here so that we save time. It was cos pi over 2x times sine pi over 4x. All right, so this is my A. This is my B. So from this identity, it is going to be half of what? Sine A plus B. So it is supposed to be sine of A plus B. You add those two. Pi over 2x plus pi over 4x. So simply add 1 over 2 plus 1 over 4. Simply add those two. 1 over 2 plus what? 1 over 4. That is going to give us 3 over 4. So it's 3 over 4 pi, 3 over 4 pi x. So that is it, 3 over 4 pi x. That is A plus what? A plus B. Then we move on minus. So that's minus sine A minus B. So we must have A minus B. All right. So that's the sine of A minus B, pi over 2x minus what? Pi over 4x. So that's 1 over 2 minus 1 over 4. 1 over 2 minus 1 over 4 is going to give us 1 over 4. So that's 1 over 4 pi x, which is simply pi over 4x. All right. So this is what you're going to have after expanding. All right. So I'm going to take this. All right. I'm going to take it as it is, guys. So bear with me here. This is the one that I'm going to take and write here. So remember, there was a 1 over 2. So you can take that 1 over 2 out. All right. Then we remain. It was sine what? 3 pi over 4x. All right. And there was a minus, remember? And this was sine pi over 4 what? Pi over 4x. So this is what you're going to have. And you must integrate this with respect to what? To x after applying that identity, just like that. So let us integrate. All right. Integrating here, sine, all right, of ax. If you're integrating the sine of ax, with respect to x, remember sine was taken from a cos which was negative, so it's going to be negative cos ax over a, all right, plus the constant of integration. So it's minus cos of the constant over that constant, all right. So if you are to consider this, this here, our constant is 3 pi over 4. That's a constant that you have here. That's a constant, 3 pi over 4. So meaning to say, it was simply going to give us negative cos 3 pi over 4 x over what? The constant 3 pi over 4. So we are now having the reciprocal minus 1 over this. Simply change the numerator denominator. So that was going to give us negative 4 is in the numerator now. So it's 4 over 3 pi, all right, times the cos 3 pi over 4x, all right? So this is what you're going to have. So take note, negative 1 over, but you have to find the reciprocal, interchange those. So it is the same thing here. This was going to be, there's a negative, so it's going to be negative. Then you do the same thing for a sine. that was going to be negative cos. So it's negative cos. All right. It's going to be negative cos pi over 4. Pi over 4x over what? The constant pi over 4. Since we have this, it's going to be a reciprocal minus 1 over this. But take note, minus minus, it's what? It's a positive. Then we need the reciprocal 1 over this. Interchange, so it's 4 over what? It's 4 over pi. So it's going to be 4 over pi. The reciprocal, all right? Times the cos pi over 4x. All right, so this is it, just like that. This is it. If you want, you can expand the brackets. You have integrated, guys. If you want, you can expand the brackets. 1 over 2 times this is going to give us minus 2 over what? Over 3 pi. The cos 3 pi over 4x, all right? And you also multiply 1 over 2 times what? Times 4 over pi is going to give us 2 over pi. So that's 2 over pi cos pi over 4x. All right, plus the constant of integration. All right, actually you're supposed to put c because we have already integrated. So you must have the constant of integration in that case. All right, so expansion can be done or can be made. So it is in your hands. It is in your hands, this simplification. All right, so I'm not going to waste your time. Let us quickly refer another question. Here we are done. We have integrated everything. So those are the steps that you can take, those expansions. Product to sum identities can be what? Can be used. All right, moving on to question 4.14. That is the part of long division. As you can see, the numerator is having the higher degree compared to the denominator. So meaning to say we can use the long division. All right, so that's 4.14. So it was going to be the divisor, which is what? X minus 4 into the dividend, which is 2x cubed minus 5x squared plus 6x plus 12, so that we can have the quotient. So division, guys, like I said, it is always, you always divide to the first term, all right? Like I said before, you always going to divide to by the first term. First term to the first term. So it's 2x cubed divided by x, which is what? 2x squared. So that's 2x squared. You multiply back. 2x squared multiplies everything that we have here as a bracket. So it's 2x squared times what? Times x. 2x cubed. 2x squared times minus 4, minus 8x squared. Then you subtract. Just like that. So subtract. That's a 0 here. Minus 5x squared minus minus is going to be positive. So that's minus, minus, minus is positive. And that's going to give us what? A 3. So this is 3x squared. Then you must drop the remaining what terms, plus 6x plus what? Plus 12 as they are. All right, so this is what you have. Divide again, first term always, first term to the first term. So this time it is 3x squared divided by what? By x. And this is going to give us 3x. So that's plus 3x, which is going to multiply everything there on this part. Everything. 3x times x, that's 3x squared. 3x times minus 4, minus 12x. Then subtract as usual. So that was the idea. This one and this one, that's a 0. 6 minus minus 12, that's a plus. 6 plus 12, which is 18. So that was going to be 18x. Drop the remaining term plus 12. Just like that. So dividing again, first term versus what? The first term. 18x over x. That was going to give us positive 18. So you multiply back to everything that you see there. 18 times 4. 18 times x, 18x. 18 times minus 4. That's minus 72. So subtract, that was going to give us a 0, this one. Then 12 minus 17, that's a plus. 72, I mean. So 12 plus 72 is going to give us 84. So we have our quotient and we have our remainder here, and remember our divisor. So meaning to say, we can rewrite our f of x with this part that we have. Our f of x is going to be represented by what? Our f of x is going to be represented by the divisor. All right, let me just write the formula. Sorry, we're going to start with q, which is our quotient, plus the remainder over our divisor. So meaning to say, our quotient, this is the numerator as it is, this one. Take it as it is, the numerator. So that was the numerator as it is. 2x squared plus 3x plus what? 18. All right, then we take our remainder, which is positive what? 84. All right, positive 84 over the divisor, which is what? X minus what? X minus 4. So that's over x minus 4. So this is it. This represents our f of x, the function that we had originally. So it is the one that we are going to simply integrate with respect to x. So integrating here, you're done. All right, simply add 1, then divide by the new power 2x to the exponent of 3 over what? 3. Plus, this is 1 plus 1, that's 2. So it's 3x squared over what? Over 2. 18, we're just going to put x, 18x. All right, plus 84. Remember, 1 over this is going to give us a ln of that bracket. All right, we are not having any number here like a 2, a 3 is just a 1. So when it is a 1, do not worry, just rewrite as it is, the ln of that. All right, plus the constant of what? The constant of integration. All right, guys, this is just a revision. Go through the introduction so that you understand more of these. This can help, all right? But for revision, I think we are together. We are together. All right, so those are the typical questions that you might have. All right, and that was it. 4.14, 4.15, which is given a product. All right, this is an integration of a product, an algebraic to a trigonometric. So by parts is the best one to be applied here. 4x times what? The cos of 4x with respect to x. So remember, by parts or using DI method. All right, that can also be used in place of our by parts in a shorter way. All right, so in our case, remember your by parts formula. I'm just going to use the one that you have in your formula sheet, all right, so that we can understand each other. That is our by parts here on our integration. So you must have f of x, g prime x, and dx so that you can use this formula. All right, where f of x, in order for us to choose f of x, we can use the islet concept. All right, inverse trig, logarithmic, algebraic trig, exponential. So we have algebraic and a trig. So that's algebraic followed by a trig. So it's best for us to choose our f of x to be algebraic. So the remaining part will represent g prime x. All right, so that is it. So using that formula, if we have got the product of this, is going to have f of x by gx minus the integral of f prime x gx dx. All right, so what is representing our f of x? We said let it be the algebraic. So our f of x is going to represent 4x. So meaning to say we're going to need what? The derivative of what? 4x, which is 4. And the remaining part is going to be g prime x dx, which is what? The cos of 4x. Just like that. All right, just like that. So our g prime x dx is the cos of what? 4x dx. So to obtain the gx, we must simply what? Integrate this. All right. That's going to give us what? Gx, which represents cos. Integral of cos gives us a sine. It's going to be a sine of what? Of 4x over the constant 4. So this is what you need in the substitution here to integrate this whole part. All right, so it was going to be simply f of x, where our f of x is what? 4x. So that's 4x times gx. This is our gx, the sine of 4x over what? Over 4. All right, minus what? The integral of f prime x, which is 4, times our gx, which is what? The sine of 4x over what? Over 4 with respect to x. So let us try to simplify this so that we can integrate. All right, if we are to simplify this, this was going to cancel 4 and 4. So that's x sine 4x minus, again, this and this was going to cancel. So you're left with the integral of what? The sine of 4x with respect to x. All right. So guys, integrating a sine, we have already talked about this from our previous integrals. It gives us a negative cos 4x over what? Over 4. So meaning to say this was going to be negative to a negative. On our simplification, it was going to be x, the sine of 4x minus this one, minus cos 4x over what? Over 4, plus the constant of integration. You have what? Integrated. Oh, sorry for that. So you have integrated. What you can simply do is to combine this part here. All right. Sorry, this is what? 4x. Just combine negative, negative. That's a positive. That's cos of 4x over what? Over 4 plus the constant of integration. All right. Just like that. So you see, guys, it is just about revision. Let us do more revision. Let us consider introductions as well. Go through the introduction of the topic, understand all the basics. We have those introductions so that can help. Where we do not have the introduction, let us communicate. That is the purpose of the community section or the comment section. All right. That was it. That was it here. Direct like that. Then determine, this is now 4.2. The integral of this, but we must use what? Partial fractions by resolving the integral into what? Partial fractions. So partial fractions, that's one of the easiest because it's just to follow up. You just have to follow up the steps, all right? So that was 5 marks for this one by resolving into partial fractions, all right? That's our 4.2. So we're going to integrate x minus 5 over what? X squared plus 5x plus 4 with respect to x by resolving into partial fractions. Remember, our partial fractions allows us to separate, given a fraction like this, a single fraction, into separate fractions, all right? From our formula sheet, we have got this idea here of our partial fractions, this presentation. If you are given f of x over this, where we have got linear factors, we can separate a over the first bracket plus b over the second bracket. If it is repeated linear, you're going to use that up to that exponent. But in our case, we have to factorize so that we can see if we are going to have a repeated linear or just a direct linear factors. So you consider the what? The denominator. Can it be factorized? This part, factorize. So that's it. Yes, is can factorize this x and x. Factors of what? 4. Products of 4, which gives us positive 5. That's 4 and what? 4 and 1. All right, this is 4 and what? 4 and 1. So that's plus 4 here, plus 1. So it means we can rewrite this one as x minus 4 over these two brackets, x plus 4. Right, sorry, here this is x minus what? X minus 5. So that's x minus 5 over these two brackets, x plus 4 into what? Into x plus 1. So this is the one that we are going now to resolve into partial fractions from the idea that I have just explained here, to say this is linear. F of x over this is going to be a over the first bracket, b over what? The second bracket, and so on and so on. So in our case, that's a over the first bracket, x plus 4, plus b over the second bracket, x plus 1. So we can solve for a and b, equating or taking the numerators x minus 5 must be equal to a. You divide this, it cancels with this, you remain with what? X plus 1. So it's into x plus 1 plus b. This one and this one cancels, so you remain with what? X plus 4. So let us find the values of a and b. How so? By equating these brackets to 0. When x plus 1 is equal to 0, it means x is supposed to be equal to what? Minus 1. So we can take that as an advantage to say when x is equal to what? Minus 1. It means we have eliminated this bracket because it will be equal to what? To 0 when x is equal to minus 1. So here on the left hand side, we put minus 1, minus 1 minus 5, that's what? Negative 6. Minus 1 here plus 4, that's positive 3b. So we can find b by simply dividing by what? By 3. So that's a negative 2. All right. The second part again, x plus 4 must be equal to what? To 0. So x will be equal to negative 4. So when you say negative 4, negative 5, that's negative 9. This will give us a 0, so you can substitute for a, negative 4 here plus 1, which is what? Negative 3 times a. So divide by what? Negative 3 to find our a. All right, that was going to give us what? A positive 3. So that's our a and b that we can rewrite or substitute into our formula, the one that we have expanded, a over x plus 4. All right, just for the sake of space, let me erase this. All right, I think as you saw it is coming from. So you're going to substitute that here in place of a. So that's a is 3 over what? X plus 4. Our b is a negative, so it was going to be negative, positive, negative, that's a negative 2 over what? X plus 1. That's separated. We have separated this. So it is going to give us these two, so you can integrate that. In our case, it was an integration. So we have to integrate this separated part. So take this as it is, then integrate. All right, that was the whole idea, guys. 3 over what? X plus 4 minus 2 over what? Over x plus 1 with respect to x. And if we check, we have already integrated something of this nature. All right, so that was it. We are done. Let us integrate. We integrated something of this nature, 1 over these brackets. And where the coefficient of x is 1, do not worry, guys. Just take the constant as it is. The ln of the bracket as it is, x plus what? X plus 4. Minus 2, the ln of what? X plus 1. So that's plus the constant of what? Integration. So those are the typical questions. You can leave it at this stage. Some they do want to simplify further. It is in your hands. It is in your hands. But that is the basic integration that we had. So please, guys, do revise as much questions as you can. This is a revision. Go through the introductions of the topic, all right, of each part. All right, so if you check and you do not find the playlist for that section, let's say you have been studying, then you say, okay, this playlist is not complete, or we do not even have questions on that part. We do not have any question on that part. Let us communicate. That is the purpose of what? The comment section. So that is it, guys. We are going to consider another section and so on.